ఈరోజు ఫస్ట్ రోజు జాయిన్ అవ్వవా? వర్క్ వచ్చి ఉంటాయన్నా? సిస్టంలో
Respected Resource Professor Dr. D.M. Vinod Kumar sir, my dear participants, very good afternoon to all. This is the last day and the last session of 6-day short-term training program on recent trends in renewable energy sources and their integration to smart grid. First 3 days, we have seen various categories of renewable energy sources, that is solar energy, wind energy, biomass, geothermal, tidal energy and related topics. We have also seen different types of hybrid energy systems. And from 4th day onwards, we are seeing operation of grid issues in utility grid, microgrid and smart grid, and resiliency in grid connected renewable energy sources, and smart grid technologies for better grid management with enhanced penetration of renewable energy sources. Today morning we have seen very important topic, that is reliability, enhancement of smart grid and using renewable energy sources. Now we are seeing artificial intelligence applications to smart grid. I thank Dr. D.M. Vinod Kumar sir, Professor of NIT Warangal, for readily accepting my invitation and ready to share his experiences and knowledge. I request Mr. Gopinath, Assistant Professor of EEE Department, to introduce Dr. Vinod Kumar sir to the audience.
Yes, thank you, sir. Good afternoon to one and all. Honorable Secretary, sir, Principal Madam, Convener, Co-Convener, and our most valued invited guest, and fellow faculty members and participants. It's my immense privilege to introduce today's speaker, Dr. Vinod Kumar, sir. On behalf of St. Peter's College of Engineering and the entire team, I heartily invite Dr. Vinod Kumar, sir. Dr. Vinod Kumar, sir, presently working as professor in NIT Warangal. Sir obtained his BE from Usmania University in the year 1979. He completed MTech in Power System in 1988 and Sir completed PhD degree from IIT Kharagpur in the year of 1996. Dr. Vinod Kumar sir has joined NIT Warangal, which is formerly a regional engineering college Warangal, in the year 1981 as a faculty member. He was a head of department during the year 2007 to 2009 and Dean Academics during the year 9 to 11, and he worked as a deputy chief warden in NIT Hostel, Warangal. He was a chairperson and Institute of Engineer Warangal local chapter during the year 2012 to 14. At present, Sir is a professor HAG of Electrical Engineering at NIT Warangal. Sir did published more than 100 international journals and conferences. Sir guided multiple PhD and MTech and BTech students. Sir is a fellow of Institute of Engineering, Calcutta, and lifetime member of System Society of India, SSI. He is a member of Board of Studies of Department of Electrical Engineering, Usmania University, Hyderabad, and JNTU, Kakinada, and Anantapur. And he is a member of Doctoral Committee of VIT with Velluru. He reviewed 2 books published by Tata McGraw-Hill Publishing Company, New Delhi, on neural network. He delivered expert lecture on neural network and fuzzy logic at various institutes. Sir, areas of interest are power system operation control, power system stability and security, neural network, fuzzy logic application, flexible AC transmission system, power system deregulation and restriction, and smart grid technologies, etc. On behalf of St. Peter's Engineering College and our organizing team, I welcome you, sir, to give your wonderful lecture on AI application on renewable energies.
Okay.
Yes, sir.
Thank you
Vinod.
very
Sir, your voice is not audible, sir.
Now it is okay?
Yes, sir. Now it is audible, sir.
Okay. Thank you, Gopinath, for your nice introduction. And first of all, I wish to thank the management as well as the coordinators of this faculty development program, Dr. Brahmaya Garu, as well as Dr. J. Krishna, for giving me this opportunity. So in this one, yeah, come back to this artificial intelligence, then we will use the word that is artificial intelligence. There is several things will come into picture. That is, it can be a artificial neural network, or it can be a fuzzy logic, or it can be evolutionary algorithms and machine learning and deep learning. Several things will come into picture. Therefore, to start with, because as in today, people are talking with respect to the deep learning as well as the machine learning, and we're having some institutions there, they will have BTech, AI and ML, artificial intelligence and machine learning, and IoT and data science, several things. Therefore, these are all under one umbrella like this artificial intelligence, we can find several words. Therefore, in this one today, I want to talk about briefly with respect to the basics of one of the paradigm or algorithm of the ANA, as well as briefly I will talk about fuzzy logic and time permits. I will talk about this machine learning now. Therefore, in this one, when you are talking about this artificial intelligence means, then what is the natural intelligence? We will have that a natural intelligence is a brain. Therefore, the brain is doing wonderful things. Therefore, we want to mimic the brain. What is the specialty of the brain? We can see. Therefore, that's why we are talking about artificial intelligence. Good old days, in the beginning of the 80s sorry, the late 80s and all that, artificial intelligence is only people should use to work only with respect to the artificial neural network. Then laterally, then we change it to the extended to the fuzzy logic. Okay, we can use it for a controller, or you can use for optimization or anything. Now, in particular the power system point of view, if it is smart grid or conventional grid, anything, people are talking about using several for publication of papers and to enhance their knowledge and all that. We are talking about evolutionary algorithms, as it can be, and in the evolutionary algorithms, mostly we use for the optimization things. Okay, then it can be single objective or multi-objective. Then most of the time, as in today, the work is going on multi-objective optimization problems compared to the single objective optimization. And one more thing, when you're talking about this optimization, this evolutionary in particular, people are using hybridization. Two algorithms, they want hybrid, and they want to check that the results are much better than a single algorithm. Therefore, like that, in case of this machine learning is nothing but most of the time the algorithms are from statistics. They are borrowed from the several algorithms like regression and what is the linear regression, as well as the what is the random forest, as well as the logistic regression, support vector machines. Therefore, once again, this one hundreds of algorithms are there in the machine learning. Therefore, in this one, suppose if we talk about a brief introduction to this machine learning, then I will switch over to the artificial neural network and fuzzy logic in this one. The machine learning algorithm, the machine learning is a data analytic technique that teaches computers to do what comes naturally, humans and animals. And most of the times we observe in the algorithm, as it may be a neural network or fuzzy logic or some deep learning, or it can be a evolutionary algorithms, all things they are borrowing from the biology. That in case of the neural network, they are mimicking the brain, whereas in case of fuzzy logic, they are mimicking the mind, whereas in case of the evolutionary algorithm, they are mimicking what is that, how the birds are flying, how the bees, ABC, artificial bee call, how the bees are collecting the food and all that, and anti-colonies. Therefore, everything based upon the biology. They are borrowing several things. Therefore, in case of the machine learning in particular, we require certain, with respect to the statistics as well as the probability theory, are required to understand what is the machine learning. So here also, whether what is the learning it may be, we'll have the two types of learning is there. One is supervised learning, unsupervised learning, and all that in the machine learning also that we can see. And most of the time, these machine learning algorithms are used to predict. To predict, they are just next instant what happens. We can predict several things. So when you want prediction, people are using the machine learning algorithms. Therefore, learn from experience. Machine learning algorithms use computational methods to learn information directly from data. Therefore, everything there is with data. Therefore, that's why we are talking data science or data analytics or whatever it may be. Learn information directly from data without relying on predetermined equation and model. Therefore, what we will do is that we are not using a model from the equation from the time we are not learning. From the data, we are determining the model. The model can be linear model or it can be a non-linear model. That is, the linear model means like y equal to mx plus c. Yeah, actually m and c, these two are the model parameters we'll call. In normal mathematics, we'll call one is the slope, one is the intercept. M is the slope, C is the intercept, but here we will call model parameters, or you can call y equal to a0 plus a1 x1, something like that. Therefore, model parameters will calculate from the data, okay, what we call training data. Then from that one, we can predict by using the x value, y equal to, let's say, y equal to f of x is there. If the model f is like a linear, y equal to a0 plus a1 into x. If you from the model, from the data, you determine the constant a0 and a1. Therefore, determine the a0 and a1 by giving the x value, I can determine the y. That is what we call prediction in case of this machine learning. Therefore, learn information directly from data without relying on predetermined equation as a model. It is not predetermined. From the data itself, we will determine the equation. The algorithms adaptively improve the performance as the number of samples of data or patterns, what we call, as the number of samples available for learning increases. That is, more samples are there, or more data is there, more accuracy you will get. And deep learning is a specialized form of machine learning. This deep learning is nothing but extension of the neural network, what we will go into study. That is some slight difference is there, but it is the extension of the neural network, deep learning. Therefore, this machine learning is a scientific study of algorithms and statistical models that computer systems use in order to perform a specific task. Whether it can be you want to predict by using for the linear models or non-linear models, or you can classify also classification problems. For example, logistics is there. It is a classification problem. And one more algorithm, support vector machines, mostly people will use. That is also classification problem. Therefore, the computer system used in order to perform a specific task effectively without using explicit instructions, relying on patterns data, and inference instead. It is seen as a subset of artificial intelligence. Therefore, the machine learning, therefore, as I mentioned, under broad terms, artificial intelligence, this ML also, machine learning also is subset. Neural network is a subset of AI. There is a machine learning algorithm built a mathematical model based on sample data, known as training data. Therefore, as I mentioned, data, what are the data? Suppose you have 100 patterns are there. Therefore, I will classify into, I will separate this data into training data and testing data. Therefore, training is most of the time 70% of the data will be taken as the training, and another 30% will be to test the network. Whether it may be a machine learning algorithm or whether it may be a neural network, you will do like the same. Therefore, based on the sample data known as training data, in order to make predictions or decisions, without being explicitly programmed to perform the task. Without programming, as I mentioned, when entire data is modeled as a linear model or non-linear model, in the equation, if a constant, will calculate the constant from the data. Therefore, after model is fixed for particular data, input is given and get the output. That is y equal to a0 plus a1x. Therefore, x is given, corresponding to y, I will get output. Therefore, the machine learning algorithms are used in a wide variety of applications, such as email filtering, whether it's by email spam or not spam, and computer vision, where it is infeasible to develop an algorithm of specific instructions for programming the task. Therefore, the machine learning is closely related to computational statistics, as I mentioned. This most of the time, what my observation is that this machine learning, they coined a name, but it is pure statistics as well as probability. If you have good fundamentals of statistics and probability, they can do wonders by using this machine learning algorithms. The computational statistics, which focuses on making predictions using computers. The study of mathematical optimization delivers methods, theory, and application domains to the field of machine learning. There's one more thing, several things we'll call data mining. Algorithms will be there to handle the large data. Therefore, data mining is a field of study within machine learning and focuses on exploratory data analysis through unsupervised learning. Therefore, in the supervised learning means we will get input corresponding to the target output of the X and corresponding labeling what we call that is Y. X and Y both are required for supervised learning. Unsupervised learning, there is no desired output. Y will not be there. Only inputs will be there. Based upon the input, then we will proceed. So most of the time, based upon the problem, suppose you want to, your problem is a classification problem. Then this is unsupervised learning. That is, there is no target here. Only inputs are there. Based upon this one, I will determine the class. For example, I was in the classification problem in electrical engineering, faults are there. Based upon the data, the faults may be LL fault or LG fault or LNG fault or triple L faults, etc. So if you supply the data, all LG faults will go as a different group, and LL fault one group, LNG fault another group, like that. Therefore, these unsupervised learning algorithms will be used for the classification problems. In its application across business problems, machine learning is also referred to as predictive analytics. That is, most of the time we are using this machine learning because there are three types of learning what you have seen. That is, one is the prescriptive analytics, predictive analytics, and prescriptive and predictive, and another one what is that, to take the decisions, okay, that analytics. Therefore, the most of machine learning is always, it is nothing but predictive. I want to predict something, that's why the machine learning algorithm comes under this category. Therefore, these machine learning algorithms will be supervised and unsupervised learning, and they can be classification or regression. What is the regression? Regression is a continuous value. Your output is a continuous. In case of the classification problem, your output Y will be it can be discrete. Two classes, binary class, or can be multi-class also. More than two class also we may have. Therefore, broadly classification and regression. And in this one, unsupervised learning, mostly these are used for the clustering, and there are several algorithms for the clustering. Cluster is also grouping, clustering is grouping. Therefore, some of the applications of this machine learning most people will use in energy production for the load forecast. And once again, in the case of renewable sources also, we want to predict what is how much power I can generate by means of the solar or wind or etc. Because both are they are dependent on atmospheric conditions. Therefore, we want to predict not long term or a short term. Every 10 minutes, every 15 minutes, we want to pose on predict. Therefore, in this, come back to this, there is a machine learning. Therefore, come back to this once again. When this artificial intelligence, mostly we will classify as symbolic intelligence. That is classical AI. We will use the prologue, natural language processing, etc., and all that. Another machine learning, as we have seen briefly, what is that? Because it is also very several algorithms are there, and computational intelligence. Then we are talking about this intelligence. It is only computational intelligence and talking. That is the study of adaptive mechanisms to enable or facilitate intelligent decision-making behavior in complex and changing environments based on mathematical models of biological systems. That is, in this intelligent way, because we will this neural network and fuzzy logic, we can also call knowledge-based systems. In neural network, knowledge is stored in some small ways, how it's stored we can discuss. And in case of this fuzzy logic, knowledge is stored in terms of rules. Therefore, when it is behaving as intelligent, that is, it can take some decision making. Therefore, in a complex and changing environment, that is, in a dynamically changing environment. Therefore, the preamble to this artificial intelligence is the man has learned much from studies of natural systems using what has been learned to develop new algorithmic models to solve complex problems. So most of the time, these algorithms are very useful when our system is very, very complex. They are unable to solve, unable to develop a mathematical model by using a complex system. Therefore, this will give lot of these algorithms are most effective in the environment. And one more thing is that when you can use a neural network, what people use when you want fastness. Suppose you want to do for real-time control, your fastness, that is, if suppose load flow analysis is there, or your security analysis, any other load frequency control, several applications on the power system which are there, you can use some mathematics. So using mathematical methods, what happens is that you cannot able to reduce the computation time drastically, like milliseconds, microseconds, or nanoseconds. But whenever you will use this type of artificial intelligence, like neural network and all that, then your time, we can reduce the time to nanoseconds based upon your process speed. Whether your processor is your i7 processor or i9 processor or i11 like that. Okay. As the process speed increases, your speed also increases with respect to the neural network or fuzzy logic. Therefore, AI, artificial intelligence, is a machine emulation of human thinking process. Therefore, this human thinking process, once again, when you are thinking, because brain we can be able to see, but how the person is thinking, we cannot see. Therefore, the thinking process, what we call ZA, or the father of the fuzzy logic, ZA, he says that the fuzzy logic is nothing but computing with words, because in our mind, whatever it may be, when a decision is there, we will not use any mathematics. All these things we talk in terms of words, of whether this is good or that is good, to take any decision, therefore we will use some linguistic variables, some words. That is why we want this emulation of the human thinking process, nothing but a fuzzy logic. Therefore, in this neural network, our role model is the brain. Okay. Therefore, in the you want to mimicking everything what the brain is doing, then you want to mimic in the neural network algorithms. But in case of fuzzy logic, our role model is the mind. Okay. And one more thing, as I was mentioned, apart from the neural network, artificial neural network, as well as fuzzy logic, there is evolution computing. All these evolution computing, the hundreds of algorithms are there, and a lot of research is going on. Therefore, all these things we are, as I mentioned, we have borrowed from biology. That is, you see, evolutionary computing began by lifting ideas from biological evolution theory into computer science and continues to look new biological research findings for inspiration. Therefore, there are hundreds of algorithms like genetic algorithms, partial optimization, the artificial decoupling, differential evolution, several things which are there. Therefore, this evolutionary computing mimic, in case this is valid in case of genetic algorithm, evolutionary computing mimic Darwinian theory of survival of fittest and principle of nature to make such process. Any optimization is nothing but a such process. When you use the word survival of the fittest means the person who is fit, only that person is survive. The person is unfit, he will be removed from the data or what there is general case. But in society also, the person who is most fit, he will survive. The person who is not fit, he will be out. Therefore, that is survival of the fittest will use one of the algorithms in case of genetic algorithm. Therefore, the evolution means improvement. Okay, so you take for example generation to generation. My grandfather and father and myself is there. Grandfather, what he used to think, his son or daughter is there, they should do much better job than what is doing. And father also, what he thinks, his son or daughter is there, they should do better job than what is doing. Therefore, evolution means improvement. Therefore, in case of optimization, whenever we talk about minimization problem or maximization problem, optimization is as it may be minimization or maximization. Suppose I want to reduce, minimize the losses, means least losses I want, minimization. Suppose I want to, there is an optimal loss I can say. And one more thing, profit, a particular organization's profit, I want to maximize there. There also I can use the word optimal profits. That is, sometimes optimal means it can be, I can increase or decrease also based upon the profit. Therefore, evolution computing is the emulation of the process of natural selection in such process. Because most of the time this is based upon the genetic algorithm, therefore we will have several things will be there. One is the selection, crossover, mutation, and all that. So, evolution of the process of natural selection in such process. Such process means any optimization, I will search, I want to pick the best one. That is the objective. Therefore, this collective behavior emerges from the group of social insects such as birds, ants, bees, bacterial foraging, humanization system, etc. Therefore, everything in the evolution algorithm, everything is based on the collective behavior. That is, you will call sometimes swarm intelligence. You see birds they want to move from one area to another area, they will move in groups. Ants, they will to store the food, okay, or the rainy season or whatever it may be, they will move in a group. While moving one point to another point, they will throw some pheromone, okay, that is a chemical. Therefore, based upon that one, they will pour the and one more thing, they will store the food. They will moving in a shortest path to reach a particular destination. And one more thing is that whatever it may genetic algorithm or sorry, this PS for birds which are flying from one country to another country or one area to another area, ants and all that, everywhere except genetic algorithm, all these algorithms are based upon the foraging of the, that is food searching. Okay, they want to store, to take bees and bees ABC, artificial bee colonies. What bees will do? They will collect the food. Ants, they collect the food. Birds, why they are moving from one area to another area? Because of the food. And food is not sufficient for them for food season. Then they will go in a longer, some few miles they will travel. Okay, and they will reach, they will stay for some time. Okay, the month or weeks, whatever, then they will go back once again. Therefore, everything they move all this, they do all these things in a teamwork or collective behavior. And one more thing, when talking about artificial intelligence, what is intelligence? Therefore, this social behavior, okay, social behavior increases the adaptability of an individual to adapt. That is social behavior from the society. We can learn several things, and such that we can increase our ability to adapt to any situation. Therefore, what this literature says, the person is more intelligent and person is less intelligent, it is based on what to check. Okay, a person is more intelligent, as well as more adaptability is there. Suppose if you go anywhere, you can adapt. You can feel like your home. If you go to South India, North India, whatever it may be, anywhere in the world, okay, not only country, world of go, you can adapt to particular place. If you are not adaptive means, suppose sometimes people will go to a new place, they will not get sleep also. Therefore, when they are not adaptive, then people are not that much intelligent, what literature says. Therefore, the swarm intelligence is nothing but a collective behavior, adaptation or group behavior. Okay, there is a relationship between adaptability and intelligence. There is person is more adaptive, more intelligent. And intelligence arises from interactions among individuals. How intelligent will arises? The person is both are same X and Y, but X is more intelligent than Y, or Y is more intelligent than X, vice versa. Therefore, intelligence arises from interactions. That is, the person who is there interacting with several people. Okay, then you will have more information. You are interacting less number of people means your information is less. Therefore, it is like generally, I will give one example with CR, class representative. That fellow will interact with all 59 students in the class out of 60. Therefore, you will get a lot of information you will get. You will get more intelligent with respect to particular institute or particular class, whatever it is. But a person is moving with 2 or 3, a group of friends, then his information is confined to only this 2 or 3. Therefore, based upon the information, they are categorizing as they are more intelligent or less intelligent, like that. Each individual in a swarm or a group, each individual in a group behaves in a distributed way with a certain information exchange protocol. When they are moving a group, each one behaves like they will information protocol, just like I was mentioned in case of ant colony. They are moving, while moving, they will throw certain pheromone. They lay down from the pheromone. The pheromone, based upon the smell of the pheromone, they will go, all the ants will move in particular direction. Therefore, now come back to this brain, because in the brain, what we have seen is that in the neural network, you are mimicking the brain. Then, when you want to mimic something, it should be role model. As a role model, you are mimicking the brain means it should have some special qualities. Therefore, most of the time, what I will say is that whenever we want to take after completing our MTech or PhD, if you want to go teaching profession, first day of the teaching, I want what we will do. We want to mimic something. You might have come across several teachers from LKG to your MTech or PhD. Therefore, who is the best teacher? Who has impressed a lot? Therefore, I want to teach like X. I want to teach like Y. Okay. Therefore, there is a role model. Therefore, in the artificial neural network, we want to consider the brain as a role model because the brain will have several biological neurons there. Okay, billions of biological neurons. Okay, and more than 10 to the power of 10 biological neurons will be there in the brain. Therefore, when you consider the role model of the brain, then what are specialties? There is some specialty of the brain should be there. Then only I will adopt the brain. I want to mimic like a brain, the mathematics. Therefore, if you see the brain, okay, for some of the functions I will talk, brain will act as a pattern recognition. The pattern, because most of the time the first question what I posed is that to teach, whenever I teach this neural network in the class, what is the need to use neural network? As I mentioned, when you want fast and accurate solutions are there, then you can use neural network. Suppose when you're using certain mathematics also, you are getting same time, then there is no need for neural network. Because the time, as I mentioned, it will take milliseconds or microseconds or nanoseconds based upon the process speed of your computer. Therefore, the brain will act as pattern recognition. I will use simple episode for this one. So pattern recognition is nothing but to recognize the pattern. Okay. Therefore, in this one, just I will give one simple episode. That is generally when I am studying 5th class, my friend was there, my close friend Rama used to sit beside me, okay, and very, very close. And after 1 year is over, his father was transferred, he left. And one more thing with respect to this brain, when you show some interest, okay, the features of the particular thing will store in the pixels of the brain. When it doesn't have any interest, it will not recollect anything. It will not remember anything. When you are having interest, you will store the features in a features means important salient features of a particular person or particular thing, anything of your subject or this store in the pixels of the brain. Then whenever you want, you can recollect. But if it doesn't have any interest, it will not remember anything. It will not store anything. Therefore, the person, the Rama, was my close friend 1 year. Okay, and after the 1 year, his father was transferred. After there is no contact at all. Therefore, after completing my BTech, when I went to Bangalore, I seen a person like Rama because after there is a gap of 10 years. Therefore, when I seen him, he looks like Rama. Even the lot of noise, his height is changed, his weight is changed, as well as the lot of noise. Okay. Therefore, still is some features are stored in the brain. Just by seeing the person, I consider he will be Rama. But there are several Ramas. We don't know. A lot of noise is there. Whether it is Rama or not, we don't know. I will go and ask, what is your name? He says Rama. But there are several Ramas to be there. Then I have to say myself, whether it is my close friend Rama or not, I will ask, which school you have studied 5th class? He says so and so. Then I can. Therefore, all these episodes, what it says that even though the 1 year we are very close friends and the 10 years gap is there is no interaction, nothing is there, I never seen that person. But just by seeing the person, immediately recollected, yes, because the features are already in my brain is there. Just by seeing that person, those are matched. And those pattern is recognized. The person, my friend Rama's face is recognized, therefore immediately recognized. Here, what is that in fraction of a second? There is no mathematics, nothing. Therefore, it is very, very fast. Even the lot of noise is there, it can remove and it can be able to recognize. Then most of the time, the brain, if you observe, most of the time, why you will get headache? So the headache of the based upon our brain. Then why a person will headache when there is a mismatch? Suppose most of the time when I want to study some textbook, okay, after 10 minutes I will get headache. Then I will keep aside. I will go for a cup of tea. And sometimes I will purchase 100 rupees ticket to watch a movie. After going to the movie, then I will coming out of the theater after 2 hours or 2.5 hours, I will get headache. Then you have purchased 100 rupees ticket to purchase headache? No. But before going to the movie, I assume the movie will be headache. But while watching the movie, lot of mismatch. That is why I will get headache. Okay, when the mismatch is there, what is going on and what I expect, then you will get headache. Okay, then for this filter, the brain also will act as filter. Filter means just like in our when I want a cup of tea, okay, then after tea is over, I want to use a hardware, the filter, to remove the tea dust. Then I have a cup of tea. Similarly, brain also will act as a filter when based upon our requirements of our body. Therefore, generally, I will give simple example with respect to filter. There are several applications are there for filter, like your power system state estimation is there in electronics image processing. Okay, several applications are there. Then, for example, this is one episode with respect to filter, so how the breed will act as a filter. Let us say I want to go to Delhi. I want to go to Delhi for 10 days. Then for entire day, I work very hard. My train is night at about 12 o'clock. Therefore, if you see some busy railway stations like Secunderabad or Chennai or Vijayawada, okay, all are very busy railway stations. So before pandemic, okay, that is daytime and nighttime, same rush. Let us say my train is from Chennai. Therefore, after going to the railway station, my train is at 12 o'clock. I reach 11:30, okay, railway station. Entire day I work, okay, and after entering, lot of noise. Advertisements are coming in, vendors are shouting, people are talking, trains are coming and going and all that. Then after entering to the railway station, okay, I searched for a seat, I sat somewhere. At the time, there is one announcement. What is that? The train which is expected at 12 o'clock, half an hour delay. Then after sitting for a while, at the time, my body wants some rest. There's a lot of noise is there, okay, still I want some rest. Just after sitting for a while, you can happily sleep for 5 minutes, 10 minutes, you can happily sleep for a while. But same noise is there in the house, we cannot. We can control this. Control is there in the house. So we can ask, don't speak, don't talk, something like that. But on the railway station, there is no control. Everyone is they will do their own business. Therefore, in spite of all that noise which is there in the railway station, we can happily able to sleep. Why? Because the brain is removing that noise, okay, temporarily for a while, then happily we can sleep for 5 to 10 minutes. That's why that is the best is in case of, as I mentioned, state estimation, image processing, speech processing, etc. People can use this artificial neural network. And brain also will act as associative memory. Associative means if you know something based upon this one, I can able to recognize some other thing. Then I can recollect. Suppose after coming to my office, I will do some work in my room, and then on the campus itself, I want to meet X, Y, and Z. Therefore, after meeting X, Y, and Z on the campus, I will come. When I come back to my room, the keys are missing. When keys are not there, or my room keys are not there, then how can I retrieve? Okay, then I will think, after locking my room, I went to meet X. I will go and ask, keys are there. It says no. I will go to Y. Keys are there. If it gives, I will come and go. Therefore, based upon this, most of the time, the associative memory problem, this type of paradigm, people will use in computer science, but in electrical engineering, it doesn't have that much application of associative memory. And scanner and brain, both are same. Scanner, what it will do? If I keep my photograph, I will replica of the photograph I will get. If I get a text, if I keep some text, is Telugu, Tamil, whatever it may be, I will get the replica of that photograph. And it will do only temporarily. But brain also, if you see the pattern, it stores in the pixels of the brain when you are having some interest. Otherwise, it will not store. Years together, and I can recollect whenever I want. That is why most of the time, scanner and brain generally will give simple example. A teacher is doing some derivation in the class, and teacher says the derivation is very, very important from the examination point of view. It may appear in the end exam or whatever it may be. Therefore, out of the 6 students in the class, 5 students mostly, okay, they may not interest in the derivation. But teacher said this derivation may appear in the examination. Therefore, the students who are having some interest, logically they will derive, and they will get what is the outcome of this derivation. But if students who are not interested, what they will do? They will memorize. In the examination appear, they will reproduce. Therefore, if on the examination day, okay, the students, okay, when the teacher has distributed the question paper and all that, the 5 students who are memorized the derivation, what they will do? They will not read entire question paper. What they will do? Whether the derivation is there or not, they will search. If the derivation is there, then immediately they will do. My God, it is over, finished. That means after reproducing, but why they will search that one? They have memorized, Anytime they will forget. If one step is out, means entire will be out. They cannot. Therefore, they will search if it is available. If it is there in the question paper, they will reproduce that what is that derivation, and they will feel relief. They will forget everything else immediately. They will not recognize. They will remember all because there is no use also. The examination is over. But the students who are having logically they derive the derivation. What they will do? Okay, they will do read entire question paper, each question number 1, 2, and all that. Then they can do the derivation at the end also because logically that is based upon the steps. You can derive the expression anytime. That is the basic difference between scanner and the brain. The scanner is like you are memorizing, and the brain is that you are logically are able to derive a particular expression or whatever. Therefore, one more thing what I'm saying is that brain will do wonders when you have some interest. And come back to the last one, brain as a plastic organ. Is brain is a plastic organ? No, it is not a plastic. The word plastic is used, okay, I can modify, I can change a plastic like a rectangle shape is there. Because of plastic, I can mold it as a square. I can mold it some triangle, different shapes I can mold. Similarly, our brain, which is there, okay, we can reprogram every instant, every day. Most of the time, if you observe the society also, a good person will be bad, bad will become good. What is happening actually? They are reprogramming brain every time. That therefore, most of the time, if you see, we will have how to control the mind. Control, okay? In the spiritual world, control is how to mind. Then with control, you can do wonders. Therefore, the brain as a plastic organ means we can modify, we can change any. Therefore, these are some of the capabilities of the brain. That is why we want to make use of artificial neural network. In the artificial neural network, we are mimicking the brain of it is working. So to proceed further, this artificial neural network, because our natural intelligence is the brain, therefore artificial intelligence is this neural network, AI. AI is a branch of computer science concerned with making computers intelligent. And AI is a field of science which concerns itself with designing and developing software that is capable of processing knowledge. Either this neural network or fuzzy logic, these are called knowledge-based systems. The knowledge is stored in terms of small bits in case of neural network, whereas in case of the fuzzy logic, the knowledge is stored in terms of the rules that we can see. And first of all, you acquire the knowledge. After acquiring the knowledge, then you have to process. The students also, they will do a BTech electrical, they are doing a particular institution. What they will do? They will acquire the knowledge. After acquiring the knowledge, if they go for a particular organization, okay, some BHEL or NTPC or some software, they will make use of their knowledge in the particular organization and applying that knowledge to manipulate an ever-changing situation. Therefore, this AI is a machine emulation of the human thinking process. The human brain is a source of natural intelligence, and truly remarkable parallel computer. Then why we are calling this our brain as a parallel computer? Because our billions of brains are there. The biological neurons are there. There is, as I mentioned, more than 10 to the power of 10, and biological neurons are there. Therefore, most of the time, what we consider each biological neuron as a one processor in our computer, but one processor can do wonders. But here, one simple biological neuron cannot do much. As a network, it can do wonders. And here, what is happening here in our brain? All the billions of neurons which are there, all they will work together. That's what we call as a parallel computer. That most of the time in our real world atmosphere also we call it parallel computer means more than one processor is there, then we call it a parallel processor or parallel computer. Therefore, the human brain is the most complex machine on earth. The brain did not simply retain a copy of the picture as a scanner would. Like scanner would, it will not retain, but recognize the knowledge on the basis of meaning. Therefore, when you arrive at some interest is there, it will store in the pixels of the brain in certain, like some as basis of certain meaning. Therefore, the brain is a fantastically plastic organ, able to constantly reprogram itself to represent and understand the world. Okay, this intelligent control, okay, as a fuzzy logic, mostly people use as a controller, but we can use for the optimization or any other thing, clustering also one can, grouping also one can use. Okay, intelligent control was proposed to increase the flexibility and extend the range of automatic control. The intelligent control used techniques from the fields of artificial intelligence, operational research, and dynamic control to sense, reason, plan, and act in an intelligent or smart manner. This list could be augmented now to include in computer science. The intelligent control means, for example, most of the time I will give a simple example like a fuzzy washing machine is there, fuzzy controller, neuro controller based washing machine. Then in which way it is separate from a conventional washing machine? That is, what the conventional washing machine which is there, whether it may be a LG brand or it can be a whatever brand it may be, what it will do? A conventional washing machine is there. If you put some laundry, then based upon the, it will not bother with dust content or anything. Okay, just it is designed for 3 cycles, 3 washing cycles, 3 times it will wash out and then comes out. Then if the intelligent washing machine is there, suppose it is based on neuro controller or fuzzy control washing machine is there, then what happens here? It will check what is the weight of the laundry and what is the dust content. The dust content is less on the clothes, it need not go to 3 cycles. 1 cycle, 2 cycles is sufficient. Unnecessarily they don't go to 3rd cycle. 3rd time washing the clothes. So in that case, what happens? You can save some water, you can save your energy bill also. That advantage will come. And one more thing with respect to intelligent control, like this fuzzy TVs are there. They fuzzy logic based because whatever we are having the software, we are also having some hardware also. When hardware is there, it will become more popular, like microprocessors, etc. 8085, 8086 processors which are there. Okay, because with normal software, hardware is also there, much cheaper, then become more popular. Similarly, we are having neuro chips and fuzzy chips. Okay, and neuro chips are still costly till today. But fuzzy chips are very, very cheap. Then most of the time these fuzzy chips are used in toys, etc. etc. So who's the name? Our TV, what we will watch daily, suppose it is based on fuzzy logic. Then what happens is that most of the time the TV, the conventional TV is there. What happens? When you are watching a serial or anything, when the serial is going on, the volume is something. When suddenly after serial is over, 5 minutes or 10 minutes, then advertisements are coming, then suddenly volume increases. Then once again, by taking our remote control, we should reduce the volume. Once again, a serial started, increase the volume. Therefore, whenever you are every time increase and decrease and all that, to make it constant, the advertisement may be there, whether it's serial or whatever it may be, my volume should be approximately 50 points. Therefore, I should use a controller, intelligent controller. Therefore, it is increased the volume is suddenly increased, it will maintain some constant. Decreased also, it will maintain up to 50 like that. Okay. Therefore, this intelligent system must operate in hazardous, ill-defined, time-varying environments and complete their assigned tasks safely. Therefore, these intelligent systems or intelligent controllers should be most robust systems. Then, if you observe this one-human computer and biological system, that is our brain and the computer. One-human means it is the name of the scientist who has invented this computer, and the one-human means the sequential process. Sequential process means in a program with several steps will be there. It will execute step 1, statement 1, statement 2, like that sequentially. One statement after another statement. That type of sequential process is called one-human computer, and the brain, biological neural system. You see the processor is very complex because if you your i7 processor, i9 processor is very complex, high speed, where only mostly one only. Or some parallel computer is what? More than one of them there. But if you see the brain, they are comparing one biological neural system with our processor. Okay, it is complex, it is very simple. High speed, we only have talked with one biological neuron, which is low speed, and it requires large number, as I mentioned, billions of neurons. Then it will be much faster. Memory, we can separate from the processor because my memory is not sufficient in my computer. I can add some more memory and localize. But in case of the human being, we cannot separate. A processor is different and memory is different. No, my memory is integrated into the processor. Both are together. I cannot show separate. This is a brain. Okay, processor is different. Memory is not. It is integrated into the processor, and this memory is distributed throughout the brain. Okay. And computing point of view is centralized, The sequential, step by step, statement by statement will execute and work based upon the stored program. It may be Windows or Linux or anything is which is there, program should require. When program is there, then only you will execute. Otherwise, it will not pass. Whereas in case of biological neural system, it is distributed, it is parallel, all the biological neurons they will work together and self-learning. It will learn itself. That means, for example, I would say, because I was mentioning, learnings are two types. One is the actual three types. One is the supervised learning, unsupervised learning, and reinforcement learning. But most of the time we will use supervised learning, unsupervised learning. In supervised means, as I mentioned, input will be there, corresponding target also will be there. When target is there, I will get some output, error will be there. Based upon the error, once again the process goes on, the weights will be modified, like the process. In case of unsupervised learning is nothing but self-learning. Okay. In this case, what happens? Mostly this type of problems are used for the first and grouping. Self-learning. Self-learning, I will give one simple example for self-learning. Most of the time, if you take in our villages, a mother, one single room is there, still a mother is there, she is then kid out less than 1 year. And when she is cooking on firewood on the ground, there is no gas on the platform and all that, and the firewood she is cooking. And when cooking, the kid, it will fascinate the flame, the blue and yellow flame and all that. You want to go and touch the fire. Mother says, don't touch the fire, it is harmful to your body. But the kid can understand, he cannot. This while cooking, she want to hold, she will hold the kid and she will cook. One fine day, someone has knocked the door. When she want to attend that who has knocked the door, therefore she left the kid and she wanted. So now this kid doesn't have any control. Then what this kid will do? He will go and touch the fire. Self-learning. That is, then he realized that touching the fire is harmful. So next day, to take that kid near to the fire and his finger bring near to the fire, he will allow, he will resist, he will take his hand back. That is self-learning. That is, we will talk about, we will call unsupervised learning. Most of the time, if you see this, a fool and intelligent is there. How we can distinguish a fool and intelligent? A fool is there, the person is, there is a proverb actually. Who is fool? Fool is that he will learn from his own experience. Some problem is there, he has faced some problem and all the rest, he has learned something. But who is intelligent? Intelligent person is that he will learn from other people's experience. There is a basic difference between the fool and an intelligent person. And you see the operating environment is well defined, well constrained. Okay, without operating system, no computer will be there. But in the biological system, your brain, there is no operating system. Okay. What is the basic difference between the AI-based programming and traditional programming? The traditional means, suppose I'm having a set of non-linear algebraic equations like that. Whenever we are having simultaneous non-linear algebraic equations are there, then what I will do? If I want to write a program, okay, I can use a numerical technique. The numerical technique can be the Newton-Raphson method, Gauss method, or Gaussian method, etc. Then when you write a program to execute something, okay, the root law or some other thing which is there, we cannot separate in that when everything looks a program only. I cannot say that this is knowledge is a program. No, your program and knowledge both are embedded together. That is the traditional program. But in case of artificial intelligence, as it may be a neural network and fuzzy logic, we can show separately knowledge is different from the program. Program is different and knowledge is different. Therefore, we can interact by means of the knowledge which is stored separately. I can show, oh, this is knowledge in neural network, this is knowledge in the fuzzy logic, like that I can show. And program the work will. That is the basic difference between the traditional programming as well as the AI. That's why in particular the neural network and fuzzy logic people will call as a knowledge-based systems. Okay. And you see this biological neuron, okay, biology nothing to do with us. As an engineer, we require an equation. Therefore, to model this biological neuron, just to see this how the biological neuron consisting of, you have studied in your high school level. Okay, it consisting of biological neuron consists of a cell body, we call nucleus, dendrites, they will act as a receiver, receive the information, axon, they will act as a transmitter, transfer the information. And one more word which is there, synapse. What is synapse? If two neurons are there in between interconnection which is there, we will call synapse. Same this word synapse in our neural net, ANN, artificial neural network, is called synaptic weight. That is why the synapse, this word, we borrow from the biology. Therefore, the biological point of view, see what is the meaning of this biology, because it has a cell body, dendrite, diagram, and connection between one neuron to another neuron. Therefore, it is a functional unit between two neurons. An axon strand, what is the axon? It is transmitter. Axon strand of one neuron and the dendrite of another. The dendrite and axon, which are connected together between two neurons, therefore the information which is transmitted from axon and received by the dendrite. That is why an axon strand of one neuron and a dendrite of another. That is, between interconnection, we'll call that as synapse. Or synaptic weight we will use. Weight is nothing but small number. Okay. Therefore, the biology will not help us for engineering. Therefore, I want to model. For anything, if you use the word model means I will get an equation. Suppose, for example, modeling of a transmission line. I will model the transmission line representation point of view is by single line representation. But how can you model? Most of the time you might have seen based upon the transmission line. That is your will use pi model or K model. Then most of the time in simulation point, if you want to write a program, you will use a pi model only. Why will you use pi model? A number of nodes are 3. Whereas in case of the P model, the number of nodes will be 4. Therefore, thousands of lines will be there in a particular system if you consider. Therefore, if you can use this or that. But mostly we will use in the simulation of the transmission line, I will use pi model only. Because one node is less than the T model, therefore my computation speed enhances. Computation speed will be reduced. Okay. Therefore, if you see the neuron is more or less, suppose inputs are there, I want to solve particular problem, let us say, inputs are x1, x2, dot, x. There's a number of inputs that based upon the problem, okay, and here from inputs x1, x2, dot, xn inputs are there, which is connected to this neuron, okay, neuron shown a circle and summation, and I will connect by use of weight. Weights are W1, W2, dot, W. What is the weight? Weight is nothing but a small number. What is a small number? It can be based upon the what it should be. The weight should be greater than 0 and less than 1. And weight should be this weight, or synaptic weight, or simply weight, what is the called. We will specify as a positive numbers as well as the negative numbers. Both should be required. Only positive, my network will not learn. Only negative, my network will not learn. Therefore, the weights, suppose n number of weights are there, I can generate between plus and minus 0.25. In that range, minus 2.5 and plus 2.5. So 0.25 I will generate, or minus 0.5 and plus 0.5, plus and minus 0.5, like that. Greater than 0 should there. Weight is 0 means what? When W1 equals 0 means there is no connection at all. Then we'll call weight is there. And one more thing, in this modeling, when we are getting this output of this node, summation node, instead of I calling as net or net input, what you will get? It is nothing but x1 w1 plus x2 w2 plus dot xn w. Suppose if I stop here itself, then what happens? My neuron is a linear neuron, summation is a linear. But most of the time, our problems are non-linear in nature. The problem is non-linear and the neuron is linear, we cannot solve. That's why therefore to make the neuron a non-linear, we will use a non-linear function or non-linear activation function. Therefore, I will come back to this point. This non-linear function will be like that. It is a S-shape, we will call sigmoidal function. The input is the x, output is f of x. The output of this function I will get 1 by 1 by 3 to the power of minus x. If you use a tan hyperbolic function, tan function, input is the x, output is the y, output is the f of x. The expression e to the power of minus x by e to the power 1 minus e to the power of minus x by 1 plus e to the power of minus x. Okay, minus is missing here. Therefore, the Gaussian function, sigma will be there, mu will be there. Like that. Therefore, based on these three are continuous activation functions. What is the continuous activation function? If you take the derivative anywhere on this either the sigmoidal function or on this tan hyperbolic, the function exists. And we will have the continuous activation function and the discontinuous activation functions also. What are the discontinuous activation functions? Like step 0 to 1, or we can have the step value +1 in the first quadrant, and we can also another -1 in the third quadrant. Therefore, plus and minus both. Therefore, when you are based upon the problem, when you are using this discontinuous activation function, if you take this, if some algorithm requires some derivative, then if you use a discontinuous function, derivative will not exist. It will become 0. Therefore, I cannot proceed further. Therefore, based upon the problems, for some problems we will use here continuous activation function. Sometimes we will use discontinuous activation functions. We will use the name for the activation function. We will use a nonlinear function, or activation function, or another name, squashing function. There are several names will be there. Therefore, with respect to if I assume it's a nonlinear function, black box, you can say sigmoidal function or tan hyperbolic function, anything. The input is the net. What is the output? Output is the function of the net. What is this function? What type of function you are using here? Whether you are using sigmoidal, whether you are using tan hyperbolic, we are using sigmoidal function. What you will get? Output is 1 by 1 plus e to the power of minus net. Input is the net, therefore you get 1 by 1 plus e to the power of minus net. Therefore, this is a simple modeling of neuron, and most of the time people will use this type of neural modeling only. But in literature, there are complex modeling are also available. But very rarely those modelings are used, but this is very, very popular. Mostly in MATLAB toolboxes, also people will use this type of modeling of a neuron. So you see the artificial neural definition of the ANN, what is the general definition? From this one we can get several things. A neural network. What is neural network actually? A neural network will be like this. Artificial neural network, or simply because a neural network, because when I'm using the word neural network, it's not about artificial ANN. Whatever natural neural network is, our brain is a natural. Okay. Therefore, in this, before talking about this definition, I will come back to this point. Different layers will be there. One is the input layer, output layer, and there is the hidden layer. How many layers, how many nodes are required in the input layer based upon the problem. For example, I want to solve efficiency of a transformer. If you want to compute efficiency of the transformer, how much data is required? You require output of the transformer, you require iron losses, you require copper loss. If 3 data are there, okay, then I can calculate efficiency. Therefore, if you want to solve this problem, you can have 3 input nodes, 3 nodes will be required. Here, single output is sufficient here in case of this output layer. Hidden layer. So, how many hidden layer nodes are there? There is no hard and fast rule, and but only as a thumb rule, what it says in particular the one of the algorithm, my hidden layer nodes should be approximately 1.5 times, 1.5 times the input layer nodes. Therefore, like that we will fix hidden layer. It need not be exact. That's why we use the word approximately 1.5 times, slightly more, slightly less off. But the condition is that hidden layer node should be number of nodes should be more than the input layer node. Therefore, the question comes more means how much more. That is why the thumb rule says approximately we should have 1.5 times the input layer node. Therefore, this is the input layer nodes, input layer, hidden layer, output layer. Therefore, in this one, this is one neuron, this is another neuron interconnection. Then what we have seen, that is this topology of this neural network, we will call feed forward neural network. Like your control system, you know, feed forward, that is open loop control system and closed loop control system. Closed loop means the feedback will output is go back to input and output. So here also, there is input layer, hidden layer, all the connections are there. Hidden to output, once again all the connections, and this is your output server. The ith layer it will call, this is jth layer, this is kth layer. Therefore, in this one, when the signal is processing from inputs, it is moving from input to the hidden to the output. Therefore, when it is supervised learning is there, here your targets also will be there. This is your calculated output, your targets will be there. Your target or desired both are same, minus your calculated output. Because these weights which are there in the connections, whatever we have shown, we should assign certain weights. Weights are nothing but small number. How many weights are there are required with respect to this neural network? Okay, 3 into 2, 3 to the 6, 6 weights are required. This is 1, 2, okay, this is 1, 2, 3 are there, W11, W12, okay, and W21, W22, something like that. Therefore, these are your, we have to initialize the weights between, as I mentioned, range, plus and minus 0.25 or plus and minus 0.3, something like that. Therefore, then if you get in the first step, okay, you are getting the output, your target is there, last error is more. Based on the error, I will propagate backward. Output figure, I will go to input, hidden layer. Well, going back, we have forward pass and backward pass. While going backward, I should modify the weight. How we can modify the weight? To modify the weight, we should have expression. You should remember W new equal to W old. W is the weight. Okay, weight is like a small number. Okay, W new equal to W old plus change in the weight expression. How we can change the weight expression delta W? We can get the change in the weight delta W from the learning rules. The learning rules are the heart of the artificial neural network. Therefore, I will initialize the weight, I will do the error, and the one condition is that error corrects the weight. When error, you want to reduce the error means you have to modify the weight according to certain law. Suppose another one, what is this? The feed forward neural network, like an open loop system and control system. In the closed loop or feedback, we will use the word here in case of neural network, we will call recurrent neural network or feedback neural network. That means your output, whatever is there, will take the tag, the signal, and will give to the input. Output to the input is feedback. Output of the input. Therefore, this type of things will call as a recurrent neural network and all. Then it is a feed forward neural network, input layer, hidden layer, output layer. Okay. And come back to this definition. So what definition says, a neural network is a massively parallel distributed process. Good old days, this neural network, another name people used to call PDP. PDP means parallel distributed process, because all the neurons, they will work together. Okay, then we will call PDP, parallel distributed process, that has a natural property of storing experimental knowledge. Okay, therefore in this one, you store experimental knowledge in terms of small weight, small number, and making it available for use. After storing that knowledge, I want to use this out. Okay, it resembles the brain in two respects. Which one? First one, knowledge is acquired by the neural network through learning. Even if you observe any human being, how you will acquire the knowledge? A kid is there. A kid wants to go to school. Okay, after 3+, the kid was admitted in a school. Then in LKG. Then what teacher says on paper, if she writes, she or he writes A, like this, like 3 lines, like. Therefore, the kid don't know what is that alphabet, what is that now, how to write, we don't know. If you don't know, therefore, he will take his hand, either will take his hand, he will write this line, right. So what we are doing, the kid is repeating this A several times. It may be 100 times, 2000 times, but finally he has learned. That is what we want. That is what we call the knowledge of alphabet A, he acquired. Then how we acquired? Knowledge is acquired by the neural network learning or training process, repeating several times. Okay, then we will get the knowledge. Because in the neural network, there are only two things are there. One is the training, another one is the testing. Training or learning, both are same. Another one is the testing. Therefore, when we are having two aspects of the training, two things. One is the training, another is the testing. Training time you will not take into consideration. Training can take, a lot of data is there, it will take 10 minutes, 15 minutes. Because good old days, our memory was only very small in late 80s and beginning of the 90s. At the time, my memory was only 256 kilobytes. Now we are talking of terabytes. Okay, at the time, memory was 256 kilobytes. Therefore, when data is specified, or the data is there, it used to take 24 hours or sometimes 48 hours. Suppose the individual power is off, means once again it will start from the beginning. Therefore, this is about our training time. Training is always offline. It will take any time, because in the class as a LKG, okay, kid who is IQ levels are high, that fellow one day one alphabet he can finish off. Second day another alphabet like that. The kid average student is there. It may take 2 days, it may take 3 days to learn one alphabet. Okay, this is a training. Okay, training or learning the neural network. Therefore, knowledge is acquired with the neural network through learning process. Therefore, this interneuron connection strength, one neuron, another neuron, which is what we have seen, interneuron connection strength known as synaptic weights or simply weights. As you have seen, the synaptic, the word is borrowed from the biological neuron, okay, synapse, what we have used. See, synaptic weights are used to store the knowledge. Therefore, knowledge is stored in terms of the weight. Therefore, this how the one more thing I will ask. It is that whenever we are having this network, a neural network is there, I initialize the weights, inputs are given, and outputs, target outputs are given, error is coming. Error, I'm moving backward from output to the hidden, I will modify this weight, and hidden to input, I will modify this weight. There is W equal W word plus delta W. As I mentioned, this delta W you will get from the learning law. So there are several types of learning laws. The supervised learning is there. There are several learning laws are there. For example, a perceptron learning, delta learning, as well as the Vitterov learning. If you take the unsupervised learning, you will have the competitive learning, and one more thing, FBL learning is there. Okay, like that in case of unsupervised learning. Therefore, this a algorithm which is there, it will move. For example, back propagation algorithm. The inputs from input to the hidden to the output are going, and back from output to the hidden to the one, they are going. Then finally, the weights are stabilized. So the weights are stabilized means knowledge has, the network has learned, network has trained. Then when network has trained means what if I want test, training and testing. So just like in the school, LKG, all the children, all the kids have learned the alphabet within 2 months, let's say. The teacher wants to conduct exam, then testing, that really they learn or not. Therefore, teacher wants, if she or he asks, write A to Z, everyone can write. On writing A, associative memory. After B, you can write. After B, you can write C. After C, you can write D, associative. If you know one thing, I can. But teacher is much clever. What he or she has done, they want to conduct some dictation. Write B, write D, write P, write Q, like that. If you know the dictation means, if you know the teacher exactly, then only you can able to write. Otherwise, you cannot. That is why at the training and testing, if you generate the data, or when you are generating the data, 70% is kept aside for the training, and the 30% is kept aside for the testing. Therefore, when network has learned, the weights are stabilized in case of neural network. When weights are stabilized, then what happens? You have to test. How will you test? You are testing the new pattern, because testing by 30% of the patterns of testing are kept aside. At the time of testing, you should give only inputs only you have to give. You should not give any target outputs. If you give only inputs, what network will do? It will directly input to the hidden to the output comes your solution. Then I can compare what is the output of the neural network solution in hand calculation solution matching or not. If they are matching, therefore, now the question comes, why it will do very fast? Because in the training and testing, both the things are in the neural network. Training time, it is offline, you will not take any concentration. Testing, when weights are stabilized, it is moving from input to the hidden to the output. That means what neural network is doing, what my computer is doing, it is doing only addition, subtraction, multiplication, and division. Only these things it is doing. There is a computer to do the simple operations like addition, subtraction, multiplication, and division. It is very, very small, very, very simple. That is why how much time it will take this, it is based upon your network, and based upon this computer processor. Whether the processor is i7 processor or i9 processor, like that. The processor speed is more, then your testing time will be, as I mentioned, nanoseconds, in microseconds. Or if I use i3 processor, based upon my problem, it can be some milliseconds. Okay, this is about how ANN will work. Therefore, you see some of the characters of the ANNs. ANNs are biologically inspired. Okay, because of some biology, how the brain is working, they are mimicking in the case of ANN. Therefore, ANNs are biologically inspired, and ANNs are organized in a way that may or may not be related to the anatomy of the brain. Anatomy means, once again, this word from biology. If you intersect the brain, Okay, the interconnections, if you check by means of microscope and all that, if we may or may not like feed forward network, feedback network like that. They assume something, they proceed. Learn from experience. Learn from experience, learn from training or learning. Okay, some different algorithms are there. So that one, in the learning, what happens is that you will modify the weight. After that, initial weight, after the learning, several iterations are doing, weights will be stabilized. Weights are nothing but small numbers. Generate some previous examples, new ones. And what it will do is that one more specialty of the AMS is that abstract essential characters. Whatever abstract you see any paper, you will have first title of the paper, then the author's name will be there, then the after that you will have abstract. Abstract means if you read the abstract, it is like a summary of the paper. If you read the paragraph of the abstract, you know the entire gist of the paper. Therefore, similarly, abstract essential characteristics from inputs containing irrelevant data. That is, even though my data is having some relevant data, it will filter out, it will not bother. For example, as I mentioned, to compute efficiency of the transformer by using a neural network, and what the inputs are required, output of the transformer, iron loss and stuff. Apart from these three, I want to give some R, resistance referred to HV binding, X, reactance referred to HV binding, also I given. There is no use at all. Then what computer will do? These are constant and they will not do much. Therefore, that is irrelevant information. Therefore, it will not bother. It will extract. It will determine the efficiency by using only those three. That is the iron losses, copper losses, and output of the transformer. In case of learning loss, that is as I mentioned, supervised learning, unsupervised learning, and reinforcement learning. In case of supervised learning, what happens? Input is required and corresponding desired output or target, different names. Both should be specified. This is X, is Y, or D, whatever you call. Okay. This is the AN is the topology, having certain weights, W are the weight. Output is coming, Y we call actual output. Then what is happening? There is the actual output Y, and the desired output, some error will be there. Based upon this error, D minus Y is the error will correct the weight. That is, in case of unsupervised, what is the input and there is no desired output at all. Only inputs are specified. Based upon the input, it should make into some clusters group. Therefore, when we want to attack a classification problem, then people will use unsupervised learning. And most of the time, as in today, this is reinforcement learning. People are using, in particular, to the autonomous cars, driverless cars. In our engineering, we are very much interested in the electric vehicles, what we are calling. But in computer science, people research is there. People talk about autonomous car, driverless car. In driverless cars, most of the time people will use machine learning algorithms. Okay, if you use only just machine learning algorithm, what happens is that sometimes some noise is there, some stop signal is there. If things stop, it should stop. But in this one, someone has the intention remote, yes, only to look at stop. What it should do? My machine, my electric vehicle. Therefore, apart from the these machine learning algorithms, we should insert some reasoning also. Then this my vehicle will act like will mimic like human intelligence will acquire. Therefore, machine learning algorithms plus it requires certain reasoning also. Okay. Therefore, in the reinforcement learning, if you see this reinforcement learning and supervised learning looks both are same. But where the difference is that here the desired output is there, here reinforcement is there. Desired output means my input, I want the efficiency to transfer my computing, my efficiency is coming at 0.95. It will be exactly 0.95. But when you are using this reinforcement learning, how much I will give? I will not give exact 0.95. I will give only some, I will increase the value or decrease the value. Let us say I can give 0.9 only, or I can give some 0.99 I can give. Then even though this reinforcement signal is misleading relative to the desired output, still my network should learn. Then we will call reinforcement learning. Then most of the time people use this supervised, unsupervised learning are very popular. Once again, in this unsupervised learning, if you observe, as we have seen, we are using for the classification problems. It is like a clustering. Okay, unsupervised classification procedures are often based on some kind of clustering. Clustering is a grouping strategy which forms groups of similar patterns. See, most of them, I will give one simple example for this unsupervised learning. Suppose the first day of the BTech, first day of the first class. Then in the class 60 students may be there, for example, and X don't know why, Y don't know that, and all that. Then in the class, in the class at present, where 60 clusters are there, 60 groups are there, because each one is one group, 60 groups. When class work is over, one will go to north, one will go to south, one will go to west, like that. But if you observe, after some 10-15 days, what happens? This entire 60 students, they will move in groups. 3 will become one group, and 10 will become one group, 5 will become one group, etc. How they form the groups? They form the groups with the similarity, because groups of similar pattern. How they form the similar? The teacher told that you three, you two should be good friends, like that. No. A student might have gone in that class to library, other student is reading, for example, in the library. Therefore, he thinks he is also interested in reading. Like that, they will become good friends. Because friend means all the qualities need not match. One is sufficient. What is here? What is the similarity? Reading. Reading. Generally, that is the common feature between X and Y. Some another student might have gone to dhaba or a hotel. He has seen his classmate in the hotel. Then what he will think? He want to make a friendship with him. What for friendship? This friendship, now and then he can come along with him to the hotel or a lunch or dinner, etc. Therefore, it will form, unsupervised will form a clusters or groups. There is the clustering technique. There will be 100 of clustering techniques are there. Out of this 100 clustering techniques, the K-means clustering algorithm is very, very popular in this neural network. Therefore, the clustering technique is very useful for pattern classification problems. That is, any classification means, okay, I will use this unsupervised learning. One algorithm in the neural network very popular is SOM. SOM means self-organizing map. Or another name for this one, same thing, coherent. Coherent is the name of the scientist. Coherent self-organizing map. People will call KSOM, like that. For clustering procedure, it is necessary to define a similarity measure to be used for
Sir, Vinod Kumar, sir, can you unmute your mic, sir? Sir, Vinod Kumar, sir. Please unmute your mic, sir. Yes, thank you, sir.
okay. This requirement of learning law. Learning corresponds parameter changes. Here weight will changes, as I mentioned. W equal W volt plus delta W. Changes the weight I will get from the learning law. In supervised learning, there are 5 to 6 algorithms or laws are there. Perceptron learning, delta rule, and withdrawal of learning. Okay, these 3 I mentioned here. Apart from these 3, some other things are also available. Unsupervised learning, there are winner take all. Another name is the competitive learning will call. Another second one is APN learning. In the learning law, what we will do is that I will compute this change in the weight expression. Therefore, in this perceptron learning, what perceptron means, perceptron and neuron. What is the basic difference? The neuron, I can use a activation function, whereas in case of perceptron, I can use, people will use a discontinuous activation function, like step function they will use. Then they will, to distinguish the step function when you are using as a in the neural network, and the continuous activation function to distinguish. Neuron means it is a continuous, discontinuous means perceptron. But you can use interchangeably. Perceptron or neuron, both are same. Therefore, everything based upon the error is supervised learning, what you have seen in case of this perceptron. Therefore, error will get desired minus of calculator. Based upon the error, I will compute this changes. All learning laws, whether it is perceptron, whether it is delta rule, Delta rule requires a continuous activation function. Perceptron is a discrete like step function. But in case of another learning withdraw off, what is the withdraw off? Withdraw off in that one is independent of the activation function. That means the neuron is a linear neuron. Okay. So for any unsupervised learning, what is perceptron or delta rule or withdraw off or winner take all or IBN, I will compute only this change in the weight. If you know this change in the weight expression, I can modify the weights. W you could W old plus change in the weight. Therefore, this objective of any learning law is that it should eventually lead to a set of weights. Eventually lead to a set of weights which will capture the pattern information in the training sector. Then when weights are changing, what is happening is that when you are showing several times a pattern is data. Suppose my data is output of the transformer, iron loss, copper loss. There is vector, input is a vector. Output can be scalar or a vector. Then when you are showing several times to the network, then what happens is that its weights are changing. When weights are changing, means what is happening is that it is capturing the pattern information or data information is captured. Like that, when captured entire all the data information, then network has learned, network has trained, what is called. Okay, in this one, this background algorithm is very, very popular. Okay, before that, just if you see this, how to attack a problem, then how to solve a problem by using neural network. The two things, one is the training and another is the testing. In the training part, it is offline. In the training, what happens is that weights will modify. Some of the steps you see, generate training patterns. How to generate the training pattern is very, very complex. If you understand how to, for a particular problem, how to generate the data 100 steps. For example, a transformer. Most of the time, the laboratory transformer I will do for the full load, half a load, 1/4 or 3/4 like that. I can get 4 sets. I can calculate efficiency and range. But if I want 100 sets of things are there, corresponding 100 efficiencies I will get. Then how to generate? Suppose your transformer, generally, I'm giving an example. For transformer, there is no need to use neural network, but how to weight user generate the pattern? Suppose and the pattern should be generated randomly. Okay, randomly, I'm using the word randomly, and another way is linearly. Linearly, one should not generate. What happens? I will explain. For example, transformer output is 3 kVA. And if you assume power factor is 1, is a 3000 watts. 3000 watts. Let us say this is if to generate a random number, I will require a minimum number and maximum number. Then I will start 10 and 10 watts or 10 kVA, okay, and 3000 watts. The linearly means what do you mean? This one 10, 20, 30, 40, 50, 60, 70 is a linear. Dot 3000. Randomly means by using the computer program, if you use a random number between 10 and 3000, then it will generate how many if lost. Minimum is 10, maximum is 3000. Okay, how many in between? How many you want? 10, you get 10. You want 100, you will get 100. 1000, you will get 1000. Therefore, I will get 100 numbers let us say by using computer program. Then what we will do is that if we take a full load, 3000 watts. Then at full load, we know if you know the copper losses and iron losses will remain same for any type of load. But copper losses for the full load, 3000 is something, some watts. But I should calculate each output, I should calculate the copper loss. Like that, one pattern means iron losses, copper losses, output of the transformer. Corresponding, I can calculate efficiency. That's the design output. Therefore, this is how we generate the pattern. Therefore, when after generating 100, as I mentioned, 70% kept aside for the training and 30% for the testing. Therefore, normalize the training pattern. Suppose your data is very, very large because my weights are small number. If data is very, very large, then I have to normalize. I should scale down. That is the entire data. I should identify which is the minimum, which is the maximum. If you write a computer program, then you can search which is the minimum, which is the maximum. Then entire data, if you want to keep between 0.5, 0.8 and 0.1, then you can keep 0.8. Here we use. If you want 0.9, you can make it 0.9. Here 0.2 you want to keep plus 0.2. You can keep. Okay. Okay. There are several normalization expressions are there. We use this type of expression. And initialize the weight matrix. As I say, what is the weight matrix which you have seen hidden to output or hidden input to the hidden layer. Okay. The weights are there is like a weight matrix. You have to initialize between plus and minus 0.25 or plus and minus 0.5. Select a suitable nonlinear function, whether it is a sigmoidal function or tan hyperbolic function, etc. Then fifth point, map the input output pattern according to specified algorithm. Okay, that is based upon the algorithm, whether it is back propagation algorithm, whether it is a function link network, etc., etc., or a radial basis function. Hundreds of algorithms are written in your network. Then we map, train the network according to the algorithm. Then when error small, when weights are modifying, error will go down the disaster. If it is 1000 iterations, 2000 iterations, whatever it may be. Therefore, when error small, stop it. This is about the training. It is an offline. Whatever time it will take for training, weights are stabilized, will not bother. Okay. But only testing, at the time of testing, what you will do, test the neural network with a novel input pattern. Novel means the new input pattern. Then whatever the 70% of the data you have used, you should not use for testing. Other 30% which you have not used, that type of pattern you have used. And at the time of testing, you should specify only inputs, not desired outputs. Okay, you get the output, that output should match our desired output, it should match. Therefore, this is about the training and things. In Brahmega, shall I continue or shall I stop?
Yes, sir. As per the schedule, we are supposed to end the session at 3:30, sir.
Yeah.
Yes.
Okay, then I will stop. And those who are working in this one, there some people may have some doubts. They can ask. They can ask either in the neural network or fuzzy logic also. Okay, I could not able to cover because of the time constraint. If still there are many doubts when they are working, they can ask.
Yes, participants, if you have any queries related to the topic sir has discussed, you can unmute your mic and express your doubt. Yes, sir, I think we don't have any doubts, sir.
Okay.
Yes.
Yeah. Thank you. Thank you very much for giving me the opportunity. Okay. I thank once again the management of the college, as well as Brahma Garu, as well as the Jake. Thank you.
Yes, sir. Good afternoon to one and all. Honorable Secretary, sir, Principal Madam, most value invited chief guest, convener, co-convener, fellow faculty members, and all the participants. It's my immense privilege to propose vote of thanks to today's session resource person, Dr. D.M. Vinod Kumar, sir. I am, on behalf of St. Peter's Engineering College entire team, extend my very heartful vote of thanks to today's resource person, Dr. D.M. Vinod Kumar, sir. Dr. D.M. Vinod Kumar, sir, has covered multiple topics in this session like machine learning, classifications of machine learning like supervised machine learning and unsupervised machine learning, applications of machine learning, and then sir moved on to topics like brief in AI and its classifications like symbolic intelligence, machine learning, computational intelligence. Then sir classified biological neuron and artificial neuron. And sir helped us to learn modeling the artificial neuron with nonlinear functions. And then sir concluded his lecture with artificial neuron classifications and the key steps in problem solving using artificial neuron like training and testing. Thank you, sir. Thank you for your wonderful lecture on this topic called AI application to smart grid. And thank you for accepting our request. Yes, thank you, sir. Now I would like to invite Mr. Sheikh Ansar, Assistant Professor in EEE Department, to start the validatory function.
Respected today's chief guest, Dr. M. Vinod Kumar Garu, NIT Warangal. Respected Secretary Sir, Mr. T.V. Reddy Garu. Respected Principal Madam, Dr. K. Srilata Garu. Respected Convener and Professor of EEE Department, Dr. B. Brahmaya Garu. And co-convener of this STTP and HOD of the Electrical and Electronics Engineering Department, Dr. G. Jayakrishna Garu, faculty of EEE Department, and my dear participants, A very good afternoon to all. Now I request to participants to give their oral feedback so that we can improve our future programs. Please respond. Any participants? We have to think more participants can give the oral feedback so that we can improve our future upcoming programs. Hello? Yes, Mr. V. Saket. Yes, please. Yes, V. Saket. Saket.
Good afternoon, sir.
Yes, good afternoon. Please tell.
I'm V. Saketa, and I'm from Methodist Engineering College and working as assistant professor here. The topics which are covered in this STTP was very nice, and they are very useful for the faculty, especially who are interested in research areas. And this STTP was designed in such a way that starting from basics to the high end, it was so nicely designed, and I'm very glad to be part of this. And I thank all the conveners and who has taken a good initiative for this, and the faculty members also who are responsible for forwarding this to other faculty members who can be benefited. I'm very happy for that, sir, and I appreciate your all hard work.
Thank
And
you.
I'm looking forward for more of this kind. Thank you so much, sir.
Thank you. Any participants? Any positive or negative also no problem, so that we can improve ourselves to conduct like these programs. V. Srikanth.
Yes, yes, sir. Good evening, sir. This is Srikanth Velpula, Assistant Professor of KITS Warangal. First of all, I am very thankful to the management St. Peter's and the principal St. Peter's and the organizing team of this recent trends in renewable energy sources and their integration to Smart Grid workshop organizing committee. And very well, this workshop is very well organized, and the schedule is organized in a good manner, starting from the first day. And you have invited very good resource persons. From the first day onwards, Dr. G. Tulsiram Das and Dr. Srijit sir from NIT Silchar, and Dr. Y. Pradeep Kumar sir from IIT, and Ranjan Kumar Behera, and so all till day. And the last session also is very good session from NIT Warangal, Dr. M. Vinod Kumar sir. And we are looking forward from the St. Peter's organizing team for the future workshops like this. And I'm very thankful to the St. Peter's Engineering College and the Department of EEE, the organizing team. Thank you, sir.
Thank you.
Hello,
Any more
sir.
participants?
Hello,
Yes.
sir. Hello, sir.
Yes.
My name
please.
is My name is M. Chinnalal, sir. I am from TKR College of Engineering, and all sessions will give more information regarding about research and some other knowledge purpose, and it is helpful for every faculty and research fellowship persons. So I'm very thanks to all speakers and who is organized this events, this program. Okay, I'm getting more idea about this non-conventional energy sources, PV system and other sources. Okay, sir. Thank you to all, sir.
Thank you. Any more participants?
Hello, good afternoon, sir. Hello.
Good afternoon, sir.
Sir, whether it is audible, sir? Hello.
Yes, please respond, sir. Ravi.
Sir, I am Ravi Dharawat, Senior Research Fellow from VIT University. I am very happy to attend STTP 1 week workshop, FDP program. The topic relevant to my research work on hybrid integration of different scenario like grid integration issues and relevant to smart grid with intelligent techniques. So many topics I was attended, even though I lost internet facility and the faculty were organizing Ansar and M. Krishna providing facility and giving information, sharing their expert experience. It is very helpful to my research topic. Thank you to all. Thank you to all coordinators and faculty members who are organizing STTP 1 week workshop. So I was attended slot 2 and slot 3. So I was missing some of the topic, even though it is very helpful if you are sharing the PPT relevant to expert. Thank you, one and all, for sharing your experience. Thank you.
Thank you, sir. Any other participants? Yes.
Yes.
Yes. Tell me, sir. Yes.
Sir, I'm Mayur Waghela from Gujarat, and I'm working as an assistant professor here. And after attending the STTP, I have learned many new things. I really appreciate the effort taken by the organizer and all the experts. They have presented very well content, and I'm sure this kind of STTPs are very going to help us. I'm interested to attend more kind of stuff like this. Thank you. Thank you.
Thank you, sir. Any other participants, please? Any other participants? Okay. Now I request co-convener of this STTP recent trends in renewable energy sources, their integration to smart grid, co-convener and head of the Department of Electrical and Electronics Engineering to address the audience.
Vinod Kumar garu, Professor NIT Varangal, respected Secretary for 3 TV Reddy garu, Principal Dr. K. Srilata, and convener of this program, and controller of examinations of St. Peter's Engineering College, Dr. B. Brahmaya garu, other teaching faculty and non-teaching faculty, and dear participants. A very good afternoon to you all. First of all, I thank all of you for participating in this 1 week short-term training program on recent trends in renewable energy sources and their integration to smart grid.
Sir, it is internet disconnection is there, sir. Sir, internet disconnection is there, sir. Your voice is not clearly audible.
Jai Krishna, sir. 1 minute. I will change the location.
Sorry, 1 minute.
Good afternoon to you all, sir. I thank all participants for participating in this 1 week short-term training program on renewable energy sources and their integration to smart grid. And in this 1 week program, many topics were covered by the eminent resource persons. So, renewable energy generation to control of renewable energy sources, integration of different renewable energy sources to grid, issues, challenges, and opportunities for research in these topics also were discussed by the eminent persons, and also reliability achievement in integration and AI applications to smart grid also discussed. So many topics were very useful for all the participants. I think all the participants were benefited from this STTP. Such type of STTPs will be conducted in future also by our department, and I thank AICTE for sanctioning this STTP, and I thank very much our Secretary Sir and Principal Madam for encouraging us for doing such activities like STTPs, FTPs, guest lectures and all. Thank you very much. Thank you one and all for giving me this opportunity. And for the success of this 1 week STTP, Dr. Brahmaya sir, convener, has done a lot of things, and he is the backbone of this STTP, and he has talked with all the resource persons and collected their addresses and contacted, and all the things were done by Dr. Brahmaya sir. I thank Dr. Brahmaya sir very much. Thank you very much, sir. Thank you one and all for giving me this opportunity.
Thank you, sir. Thank you, sir. Now I request convener of this STTP, Dr. B. Brahmaya sir, COE and the Professor of Electrical Department, to address the audience. Brahmaya sir.
Respected Chief Guest, Dr. D.M. Vinod Kumar, Professor of EEE Department, NIT Warangal. Respected Secretary, Sri T.V. Reddy Sir. Respected Principal, Dr. Srilata Madam. Co-convener and HOD of EEE Department, Dr. G. Jai Krishna Sir. Deans, HODs, Faculty of EEE Department, my dear participants, a very good afternoon to all. We successfully completed third slot of AICTE sponsored short-term training program on recent trends in renewable energy sources and their integration to smart grid. I thank the authorities of AICTE for sponsoring short-term training program. We have resource persons from IIT Patna, IIT Hyderabad, NIT Silchar, NIT Warangal, JNTH, Osmania University, NTPC, BHEL, and APEP DCL. Out of 12 sessions, 4 sessions are taken by topmost engineers in the field. All the resource persons shared their knowledge and valuable experience. They covered solar energy, wind energy, biomass, geothermal, tidal energy, advanced power converter control for solar and wind energies, different types of hybrid energy systems, issues in utility grid, microgrid and smart grid. Smart grid technologies for better grid management, reliability enhancement of smart grids, and artificial intelligence applications to smart grid, etc. These sessions are very useful. I hope that the participants have gained maximum knowledge from these lectures. It is useful for the participants to teach subjects in this area and also to do research in this field. All resource persons and engineers agreed to share their knowledge, PPTs, to the participants to do their research after this program also. Thank you one and all for giving me this opportunity. Thank you very much.
Thank you, sir. You are always, whenever we are started this program, you are encouraging a lot to calling such a nice, eminent professors from various reputed institutes, right? Thank you, sir. Thank you for your report. Now I request our beloved principal, Dr. K. Srilata Garu, to address the audience.
Thank you, sir. Am I audible?
Yes, ma'am.
Yes, madam.
Respected Secretary and Correspondent of St. Peter's Engineering College, Sri T.V. Reddy Garu. Today's Chief Guest for the valedictory function, Dr. D.M. Vinod Kumar Garu. Convener of this 1 week short-term training program, Dr. Brahmaya Garu. Co-convener, Dr. Jayakrishna Garu. Members of EEE department, faculty members from various parts of the country. A very good afternoon, one and all. At the outset, I would like to thank AICTE at first for granting us permission to organize this this short-term training program through online, even during this pandemic period. And my heartfelt thanks to the convener of this particular program, Sri Brahmaya Garu, the co-convener, Dr. Jayakrishna Garu, and members of the faculty members of Electrical and Electronics Engineering Department, all the faculty members and the technicians of electrical and computer science, whoever has helped in organizing this particular program. The reason why I'm especially thanking the members is this is the third and final slot of the short-term training program, which we are conducting on the same topic in a short span of 1.5 month period. For any convener or for any person to organize one particular program, it may be possible to do for a 1 week training program or maximum for a 2 week training program. But to do the training on the same slot by coordinating with all the resource persons, identifying the members differently for each and every slot, following up with everybody, and to do a training program like this in a wonderful manner for 3 times in a short span of 1.5 months is not an easy task. So my heartfelt appreciations to the convener and the co-convener and the members of the EEE department for making it and for doing this program successfully for the 3 times. And this is the last lot of the short-term training program. This particular concept, the renewable energy source and their integration to the smart grid, is a very interesting and upcoming topic, which will be very useful for the research scholars and also for all the teaching fraternity. Attending for these sort of training programs will improve the teaching skill of the member and also the technical skill of a member. Somebody who is at the young age and who is planning to do his research or planning to do his PhD will get an idea on what particular concept that he'll be able to do if you can attend for these sort of training programs. We at St. Peter's do organize more such sort of faculty development programs, and I thank members trusting us and joining from various parts of the country. I hope to look forward from all the participants to join for our further programs, and I hope we satisfy the needs of your requirement through this short-term training program. I am confident that the convener and the co-convener of this program have organized the schedule in a systematic manner, and almost all the topics pertaining to the title is being justified. I once again congratulate all the members of Electrical and Electronics Engineering Department for successful conduction of this program, and I wish all the best for their future endeavors. Thank you one and all.
Thank you, madam. Thank you. You are always supporting us whenever we are coming to conduct FDP or workshop. You are always supporting and encouraging. Thank you, madam, for that encouragement we needed always from your side also, madam. Thank you, madam. Now I request our secretary, sir, Sri T.V. Reddy Garu, to give his valuable motivating speech.
Respected chief guest of today's program, Dr. Vinod Garu from NIT Warangal, Principal of St. Peter's Engineering College, Dr. Srilata, convener of this program, Dr. Brahmaya, and our HOD for Tribal department and organizing committee. Good evening to all of you, and more important, the participants. Good evening to all of you. It's nice to see, St. Peter's is nowadays very busy in completing the STTP programs, the faculty development related programs conducted by AICTE in all departments. Parallelly, we are actually conducting the outcome-based education program sponsored by AICTE, and then in this program by the Tribal department on this renewable energy resources. And this particular pandemic has created opportunities for you people to have these eminent personalities. Otherwise, you wouldn't have come all the way here, or they couldn't have come all the way here. And this technology has helped us to bring all of us together on this platform. And I would like to thank AICTE for sponsoring yet another program for us. And I would also thank all the resource persons, right, from NITs to IITs. Now today's speaker and then today's guest, Vinod, Professor Vinod Kumar Garu, and all other people. We could try to get the best of them. And some of the members have already spoken to us before in their feedback. Everybody said it's fantastic, good, and all those things. In case you would like to give any suggestions, you can please mail to us, or you can put it in this chat box, and our people will be eager to help, and then may bring those changes in the forthcoming training programs, either done exclusively by us or in partnership with the AICTE. I would not going to talk anything about your renewable energy resources, because all these trainers have spoken to you, and I personally feel that you should pass on this message to your colleagues in your department, and also involve your students in doing projects based on those things, write papers, attend conferences on these things. That will definitely help them, because the future is for the renewable energy resources only. And Tribal department faculty are the best ones to provide this, not only for Tribal, but for the whole college. If we can do it. Yeah, can you hear me now?
Yes, sir.
Yeah. If you can involve your college students, not only from Tribal but all the department people, because renewable energy resources are saving power or distribution of power. Every engineer should have an idea. So I request you to please pass on this message for knowledge sake for all the students, and in particular for Tribal department, because they are the future engineers in electricity department who can save our country, and in a lot of save energy for us also. I would like to thank our principal, and more importantly our professor for taking up this particular program, and in particular AICTE for sponsoring this. And I would like to thank all the resource persons for this third spell of STTP program sponsored by AICTE. Thank you so much.
Thank you, sir. Always you are supporting to conduct this type of programs. Thank you for your support, sir. Now I request today's chief guest, Dr. D.M. Vinod Kumar, Professor, Tripoli Department, NIT Warangal, to give his speech.
Good evening,
I request
everyone.
others to mute themselves so that we can hear to sir.
Secretary of the St. Peter Engineering College, as the principal, Dr. Krishna, and the coordinators, Dr. Brahmaya Garu, as well as K. Krishna, and faculty of the college, as well as the participants. So first of all, I wish to congratulate the coordinators for successfully conducting 3 phases of the faculty development program. Therefore, to conduct the 3 phases of the 3 weeks, it is somewhat difficult task, and they conducted very successful. So at the outset of this the valedictory address, I wish to start with some saying, that is, if you are having a hammer in your hand, everything looks like a nail. It gives a meaning. I will repeat once again. If you are having a hammer in your hand, everything looks like a nail. If you see overall, superficially, the meaning of this sentence is that, suppose most of the time, the sons or daughters, they are studying in some hostel. When they come back to the house, okay, mother says that they are not having good food, and she will cook good food and all that, and 3-4 days he will have the good food, and after that no work, he will watch the TV and having the lunch, dinner, etc. Third or fourth day no work. Suppose in the house he will see some hammer. If by taking this hammer, he want to anywhere in nails are there. Nailing, that is what I will say, on the wall or the table, etc. Even though there is no nail, if the hammer is there in hand, he will go and hammer. Then based upon this one, when the hammer is nothing but with respect to our this technologies and all that, we should have several technologies. When we are having several technologies, just by seeing you want some research or you want to do something new work, therefore we can, everything looks like a name. That is, the problem is like a name. Therefore we can solve by using this technology. The technologies can be based upon your renewable sources or integration, or can be a smart grid, whatever it may be. And one more thing, as I mentioned, the technology goes on changing. As of today, people are talking as of today, that is cyber physical systems. Whenever you say this cyber physical systems, okay, the cyber is nothing but, the cyber means it can be computation, it can be communication and controls put together. We'll call it the cyber, that are discrete or logical. That is, the cyber means computation or communication and control. The control you can do as a discrete or logical. Therefore, this most of the time, this in cyber, this is cyber. The physical system is nothing but our whatever man-made systems, that is generation, transmission, and distribution. Therefore, in this most of the time, what I was mentioning in this one of the second phase of the FDP, the communication is also part of the electrical engineering. Without communication, we cannot go for the smart grid. Therefore, this computing and communication system bridges the physical world, which are referred to as cyber physical systems. Therefore, this is where integrating both our different types of computation and communication and control, as well as with respect to the physical systems, that may be a generation, transmission, or distribution systems. Therefore, and one more thing, to learn this type of new things, okay, wherever, because several things are there to catch hold of. These things will take some time. Therefore, we should be very fast. Therefore, to bringing out hidden talents, we can bring out everyone will have some talent. Therefore, to bring out this our hidden talent, we should develop challenging spirit. When we are having this challenging spirit, we can do wonders. Challenging spirit, as well as then only we can reach our goals. Then to do this one, we should change our mindset. Therefore, when mindset is changed, just like I was mentioning in the neural network, our mind, okay, we can reprogram ourselves. A person can be good or bad. I want to learn, or we don't want to learn also, based upon the person. Therefore, when you change our mindset, okay, we can do any wonderful things. Therefore, based upon this one, when you change our mindset, our creativity enhances. When your creativity enhances, then we can do wonderful things, and we can do whatever your goals are there, we can achieve those goals. Therefore, in this thing, okay, as an institution, as a college, okay, we should have a good teamwork in, as well as the time management. These two things are essential. Then institute also will grow, as well as the faculty member also will have some. You can develop, you can publish papers. Okay, I will stop here. Thank you very much for giving me this opportunity. But once again, I will thank the coordinator Brahmaya, as well as the Jay Krishna. Thank you very much.
Thank you, sir, for valuable, that means an importance of technology you explained. Thank you, sir. Now, this 3 slots of recent trends in renewable energy sources and their integration to smart grid, this STTP we coming to end. Now, I would like to give the vote of thanks. First, I would like to thank authorities of AICTE for sanctioning this short-term training program. Recent trends in renewable energy sources and their integration to smart grid. Now I thank co-convener and head of the department Triply, Dr. G. Jaikrishna, for giving his support in organizing the STTP. Thank you very much, sir. Whenever you are coming in the morning, you are telling that how we are going to, how many participants join, like that. Very enthusiastically you done for your support. We really thank, sir. Now I thank the convener and the professor of Triply department and COE, Dr. B. Brahmaya Garu, for arranging this STTP program on recent trends in renewable energy sources and their integration to smart grid. Sir, we are very happy to tell you, you invited senior professors from IITs, NITs, JNTUs, OU, Osmania University, and apart from that, you invited topmost engineers from NTPC, BHEL, and AP, EP, DCL. Very eminent persons you invited, sir, so that the participants and that faculty of electrical department most be benefited. I thank the convener Dr. B. Brahmaya for successfully completing this STTP. Now I thank the principal madam, Dr. K. Srilata Garu, always madam giving guidance and directions and motivations for the entire electrical department for successfully completing this STTP. Thank you very much, ma'am. Now I thank the secretary, sir, Mr. T.V. Reddy Garu, for overall support and encouragement. Always you are giving overall for us. Always you are giving overall support and encouragement and motivation whenever we are conducting that to conduct successful for completing this STTP. Now I thank to today's chief guest, Dr. D.M. Vinod Kumar, NIT Warangal, Professor of Electrical Department. Thank you very much, sir. You are that means just now only you told that the importance of technology. Thank you so much, sir, for your support and for your accepting our invitation 2 times, I think, in the second slot and this slot also. Thank you very much, sir, for accepting our invitation, for your motivational speech and effective lecture. Thank you very much, sir. Now I thank all EEE department faculty for their continuous support for conducting this STTP. I especially thank Mr. Gopinath always for monitoring whenever we are getting any technical problem, for monitoring all these that means links or feedback links for doing all these things. I especially thank Mr. Gopinath, and I thank to the non-teaching staff, Mr. Rofus and Naresh, for their support. Now I thank to one and all who directly and indirectly helped in organizing the program and making a grand success. Thank you very much. Thank you all.
Okay.
Thank
Thank
you.
you, Brahmendra. I will leave.
Thank you,
I
sir.
thank all EEE department faculty, non-teaching and teaching, for supporting, for completing this STTP successfully. Thank you very much.
Okay. Thank you, Jaykrishna. I am leaving.
Thank you, sir. Okay, we can end this session.
Feedback form. Tell about feedback form, sir.
Okay,